Okay, the last lesson for languages and automata for Math 2. So, we have seen a regular expression like A or B star A or B star B. If we look at the corresponding graph, then by now you can draw it. Let's check whether it works indeed. So we start at an initial state as 0, and then we can choose A's or B's as often as we like. That's this part. If we like to continue, we go up with an A and go to the next state, this one. Then again, I can choose A's or B's as often as we like, and when we're done, we do for the last time choose a B, and we end in S2, which is an accepting state. But of course, if you look at this graph, then you see that the computer has a lot of problems with it. And the biggest problem is the one we encounter already at the beginning. If we're in state S0 and we get an A, then what do? Shall we stay or shall we move up? These choices are too difficult for a computer. So we have to change this one in an FSA, an finite state automata, in such a way that the computer knows what to do in any amount of time. However, because now we have two options from one state, we cannot just add things. So we have to learn a new solution method. Okay, if we look at the original one, then the new solution method would be we start from S0. Nothing spectacular about that. And if we're in S0 and we get an A, then we could either go to S1 or stay in S0. So what we do is we define a new state, and this state in fact is a combination of S0 and S1. And if we get an A, we go to S0, S1 as a combination. If we get a B, we just stay in S0. So that's not a problem. So B just stays as it was, but for the input A, we have to make a new state. And that could be either S0 or S1. Okay, now I'm in this state. It's a combination of S0, S1. So if I get an A, I have to check this out. So if I'm in S0 and I get an A, then again I can go to S0 or S1. And if I'm in S1 and I get an A, then thank God there is only one option. I go to S1. The three possibilities here, so S0, S1, S1, is the new state. And thank God S1 appears twice. So this combination again is the set S0, S1. So apparently if I get an A, I just stay where I am. If I get a B and I'm in one of these states, okay, from S0, if I get a B, I go to S0. And if in S1 I get a B, oh dear, oh dear, oh dear, then again I have two options. I can go to S1 or to S2. That means if I get a B in the state S0, S1, then as a result I have three possibilities. I could stay in S0, go to S1 or to S2. I have to make a new set, a new state. So with a B, I go to a new state, S0, S1, S2. Okay, so if we are in this state, S0, S1, S2, and I get an A, what will happen? For S0, I get an A, I can go to S0 or S1. In S1, if I get an A, I stay in S1. And if I'm S2, that's easy. I can't get an A. So for these three combinations, if I get an A, I go back to the combination S0, S1. And what happens if I get a B? Well, in S0 I get a B, I stay in S0. If I get a B in S1, I go to S1 or S2. S2, I don't do anything with the B. So that means that if I get a B, I will stay in this state, the combination S0, S1, S2. Okay, now there's one option still left. When can I finish the word? And then you check in the original graph in what state we could officially finish, and that's only in state S2. So we check, where do I find S2? Well, only in this one. So this is my only possible finalizing state. And now we have a new graph, which is an FSA, which we can use for the computer. He doesn't have any choices. He knows where to start. And with every input, he knows where to go to. Big problem, as you already seen, if I have a few states, that's not a big deal. But if I have 6 states originally, then you can have a lot of combinations. And in total, the possible combinations are 2 to the power of the number of the original states. So that could give us a lot of misery. Let's try to make an infinite state automata of this language, of this graph. And so immediately you see it's not a finite state yet because it has 2 entry points. And for a finite state automata you need to have only 1 entry point. So let's start by making this first entry point, and that's a combination of S0 and S2. Then from this new state we have to check out all possible exits. So let's start with 0. So if we go from S0 out with a 0, we stay in S0. And if we leave S2 with a 0, we go to S3. So that's a new state, a combination S0, S3. If we leave S0, S2 with a 1, then from S0 we go to S1. And from S2 with a 1 we stay in S2. So again, a new state. Okay, this one is done. So let's continue with S0, S3. So if we leave S0, S3 with a 0, if we leave with from S0, we go to S0. And from S3, if we leave with a 0, we go to S2. But now we are in luck, because you see, we already have that one, S0, S2. So I can erase that last one. So I erase the last one, and then with a 0, I just go back. If I'm in this state and I get a 1, so from S0 with a 1, we go to S1, and from S3 with a 1, we stay in S3. Okay, great, done. So let's look at S1, S2. So in S1, if we get a 0, we stay in S1, and in S2, if we get a 0, we go to S3. We have that one, 0. If we leave from S1 with a 1, we go to S0, and if we leave in S2 with a 1, we stay in S2. So we go to that state. We already have it. Done. Then one last to go. Let's hope we don't need to make another new state. From S1, S3 to, if we leave with a 0, S1 with a 0, we stay in S1, and S3 with a 0, we go to S2. So S1, S2, that's this one. And then if we get a 1 in S1, we go to S0. And if we get a 1 in S3, we stay in S3. So that would be that direction. Okay, well, that wasn't too bad, huh? So the only thing now we need to do is enter the exit point. So when can we stop this language? So let's make them red. And then we have to color all combined states where one of the original exit points is there. So S1 is in this one. So this is an exit point. This is an exit state. And S2, that's this one. So the only one we're not allowed to leave is S0, S3. And then this is a nice finite state automata. So the only thing left to do is now the mock exam of Math2. Hope you enjoyed this series of videos. If you have any questions, please don't hesitate to contact me, and good luck with the exam.